Morning students. Today we will continue with our chapter number 2, Elements, Mixtures and Compounds. In the last class we have studied about elements and the different types of elements. Today we will study about compounds and mixtures. Compound is a pure substance formed by the chemical combination of two or more elements in a definite ratio for mass. For example, carbon dioxide is a compound made by combining two elements, carbon and oxygen. They are in the ratio 12:32 by mass, that is 3:8 by mass, and by volume the ratio of carbon and oxygen is 1:2. In a compound, the original properties of the constituent elements are lost and substance formed, the new substance which is formed, it has totally new properties. For example, water is a compound which is made up of two elements, hydrogen and oxygen. They both chemically combine in the ratio 1:8 by mass. Hydrogen is a combustible gas and oxygen is a supporter of combustion. Whereas water is a liquid and it is neither combustible nor a supporter of combustion. Similarly, carbon dioxide also, it has totally different properties from its constituent elements, carbon and oxygen. The smallest unit of a compound is a molecule. Molecule exhibits all properties of a compound. The molecule of a compound contains atoms of different elements. For example, molecule of carbon dioxide, it contains one atom of carbon and two atoms of oxygen. Molecule of water contains one atom of oxygen and two atoms of hydrogen. The molecule of nitrogen oxide contains one atom of nitrogen and two atoms of oxygen. The molecule of calcium oxide contains one atom of calcium, and a compound is made up of only one kind of molecule. But the molecule of one compound differs from the molecule of another compound. That is why all compounds have their unique properties. For example, if we take a molecule of sodium chloride, so all the molecules in sodium chloride are identical. Similarly, if we take the molecules of carbon monoxide, so all molecules of carbon monoxide will be identical. However, there will be difference in the molecules of sodium chloride and the molecules of carbon monoxide. Thus, the properties of both of them are different. The compounds can be represented by the chemical formula. That chemical formula gives the number of the atoms of each element in one molecule of the compound. Here is a table giving the name of compound, its chemical formula, and the number and type of atoms in a molecule. So water, the chemical formula is H2O. Water contains two atoms of hydrogen and one atom of oxygen. Carbon dioxide, chemical formula CO2. One carbon atom is present and two oxygen atoms. From the chemical formula only we can come to know which elements are present and the number of its atom. Nitrogen dioxide, NO2, one nitrogen atom and two oxygen atoms. Calcium oxide, CaO, one calcium atom and one oxygen atom. Zinc chloride, ZnCl2, one zinc atom and two chlorine atoms. Sodium chloride, NaCl, one sodium atom, one chlorine atom. potassium hydroxide KOH, one potassium atom, one oxygen atom and one hydrogen atom. Mixtures. Mixture is an impure substance. It can be defined as two or more kind of substances, may it be element or compound or both, physically mixed together in any proportion such that they do not undergo any chemical change are called mixtures. For example, tap water. It is a mixture of water and some mineral salts. Lemonade, it is a mixture of lemon juice, sugar and water. Air is a mixture of many gases. Soil is a mixture of clay, sand and various salts. Milk, ice cream, tea, smoke, wood, etc. all are examples of the mixtures. Alloys are the mixtures of metal. The substances that form mixtures are called components or constituents. The constituents of the mixture retain their properties. That means the property of the element or the compound present in the mixture is not lost because there is no chemical reaction. For example, in a mixture of salt and pepper, the particles of salt retain their saltiness and the pepper retains its spicy taste. A mixture doesn't have a definite set of properties. Its properties depend upon the proportion of the constituent in which they are mixed. Thus, the properties of a mixture can be changed by changing the proportion of its constituent. For example, suppose we make a sugar solution. If the amount of sugar is more, we can taste the sugary taste of the solution. If the amount of sugar we keep less, the solution will be less sugary in taste and vice versa. Similarly, milk, it is a mixture of fat, carbohydrate, protein, salt, vitamins and water. We can lower the fat present in the milk by decreasing the concentration of fat. The differences between mixtures and compounds. Mixtures are the impure substances. Compounds are pure substances. Mixtures are made up of two or more substances mixed physically. Compounds are made up of two or more elements combined chemically. In mixture, the constituent elements retain their properties. In compounds, the constituent elements lose their properties. The constituent of mixtures are present in varying proportion. They are not present in any fixed proportion. The proportions can be changed. In compounds, the constituents are present in a fixed proportion. In mixtures can be separated by the physical methods. Compounds cannot be separated by any physical method. Mixtures have no fixed melting and boiling points. Compounds have fixed melting boiling points. Mixtures have no chemical formula because they are not present in any definite ratio. Compounds have. To understand the difference between mixture and compound, we do an activity. We prepare a mixture of iron and sulfur, and we will see that iron as well as sulfur both retain their properties in the mixture. When we bring a magnet near the mixture, the iron particles will cling to the magnet and sulfur will dissolve in carbon disulfide when this mixture is dissolved in the carbon disulfide solution. So we see that both the elements iron and sulfur are retaining their properties in the mixture. Now we take the mixture and we heat it. On heating, a new compound, iron sulfide, is formed. In this we see that this iron sulfide has totally different properties from the original elements iron and sulfur. It neither sticks to the magnet nor it dissolves in the carbon disulfide solution. So it has totally different properties. So from this we make a conclusion that The compounds have totally new properties different from the elements which were used in making the compound, and in mixtures the elements or the compounds which are present, they retain their properties. Thank you.